Okay, so it's very nice to meet you finally after such a long time. I hope you guys enjoyed your winter vacations and you are fresh now for the new term. And I also hope that you got a good result. Today, I think the result was out. So even if it wasn't good, that's okay. It's a part of learning, but we should learn from our mistakes. Mistakes are good for as long as we learn from them. Inshallah. Okay, so let's get started with this chapter of static electricity. Okay, first of all, uh, what do you understand by static? Whenever I start a topic, I start with the meaning of the title. So, what do you understand by static electricity and how it is different from current electricity? And is it different or not? I cannot see Zainab, the one who requested for this class. Okay, what do you understand by static? I guess you guys have done this topic in the school with your teachers. Come on, guys, I need some answers. I need one of you to respond to my question. Yes, Ajwa? Jazakallah khair.
Static means not moving.
Okay, very good. And then how it is different from current electricity? How is it different from current electricity? Yes, your answer is correct. Static means not moving. And current is? Come on. Hala, Hafsa, Javeria, Umema.
Electricity is the movement of electrons.
Okay, so static is not moving. Electricity is moving electrons. So can we see a difference? What's the difference? Come on, I want you guys to think.
Miss, current electricity is the movement of electrons.
Yes. Yes. Okay. Yes, you guys define the two different types of electricity correctly. And so let me pinpoint the difference. Static is not moving. Okay. Static, as the terms, a static word is from stationary. Okay. Meaning not moving. And current is when there is flow of electricity or flow of charge through a circuit. Okay, so these are two different fields of electricity. These are two different, you can say, two different types of electricity, and they are studied differently. Okay, they have a few similarities, but on the whole, they are a little different due to the fact that static electricity deals with charges which are not moving. They don't have a circuit to flow through, whereas a current electricity in current electricity charges move through a circuit. And what is a circuit, by the way? What is a circuit? Whatever you understand, you can answer in your own words. I don't need a definition. Yes, Myra. What's a circuit? What do you understand by a circuit? Can a current flow without a circuit?
No, it cannot.
No. So what do you understand by circuit? Yes, Ajwa?
Circuit.
A pathway on which the electrons flow.
Yes, yes, right. So it needs to be closed. A pathway cannot have a charges flowing until and unless it is closed. I don't remember if you guys remember that. How do we turn the lights off and on? When the lights are off, we open the circuit. So when we open the circuit, the charges don't have a complete closed pathway to flow through, and therefore the charges stop flowing, and so the light is off. So that means we need a closed continuous circuit or pathway through which the charge can flow. Only then the electricity will flow, and only then you will see its effect. Whereas in static electricity, we don't deal with circuits, it's just charges. Okay, so once you understand that, now I want to demonstrate in front of you static electricity. And you might have observed it in your daily life already, but I want to demonstrate it. Okay, you can see my camera. Okay, so these are, if you cannot see my camera, please let me know. Okay, these are pieces of paper. Okay, paper is what? An insulator or a conductor? Paper is an insulator or a conductor? Okay, I am rubbing this comb. This is a plastic comb. Can you see? This is a plastic comb and this is my sweater. And I am now rubbing the comb with my sweater. I'm rubbing it. Okay. And now let's see if these pieces of paper get attracted to the comb. Like this. Muntaha, can you see? Move away. Yeah, you saw the pieces of paper getting attracted. Let me do it again.
before. Same as before, right? क्या क्या है?
Please mute yourself. Yeah.
Assalamu alaikum, miss.
Walaikum assalam. Can you see the pieces of paper got stuck to the comb? Why? Because I rubbed the comb and so the pieces of paper got clung onto it, right? Now, I have a damp piece. Sorry, I have a damp comb. You know, it's wet. Can you see the water droplets? Yeah.
Yes, miss.
Yes, you can see the water droplets. Can you guys move away? Can you guys move away? Okay, now I am rubbing this comb with my sweater again. Okay, and now this is damp. And now let's see if this comb manages to attract the pieces of paper. No, it's not. It's not picking up even one. No, right? Both are plastic, but one was dry, the other one was damp. That was the only difference. Okay, now let me also do the same experiment with this metal spoon. Again, I'm rubbing. ऐसे दिखाओ, ऐसे, हाँ. No, no piece is getting up. No piece. Okay. Now let me repeat with this dry plastic comb. Yeah, you saw the pieces of paper are getting stuck. Right. Now, okay, now turn the camera off. Okay, keep the camera on the book, on this first page. Okay, so now let's discuss what we just saw. Now, what happened when I rubbed the plastic comb with my sweater? And the sweater, by the way, was of fur. Okay, sweater was made of fur. So when I rubbed the plastic comb with my sweater, it picked up the pieces of paper. Can anybody explain this?
Because the electrons move from the comb become charged.
The electrons became charged?
The comb become charged.
Okay.
Brush the comb.
Yes. Okay. Very good. So how did that happen? Yes. Very good.
By rubbing it.
Okay. So rubbing did what?
It made the comb charged.
Okay. So, yeah. So, what actually rubbing did was that it rubbed off a few electrons of the atoms temporarily. Temporarily. Okay. It rubbed off a few electrons from the atoms of maybe the paper or the comb. It can be any, we don't know. So one of them acquired a positive charge, and you see, either the comb acquired the positive charge and the papers acquired a negative charge, or it was the other way around. But whatever the case, both of them acquired negative charges, because of which uh, they were attracting each other. Okay. And another thing that you must appreciate here is that plastic is an insulator, and so is the paper. Both of them are insulators. Okay. So whatever charges they acquired, they couldn't conduct them away because they are insulators. And so because they couldn't conduct them away, they were there where they were. I mean, they were wherever they were. They couldn't move. They couldn't flow anywhere. There was no circuit available. There was no pathway for them to flow. And so because they were staying where they were, the opposite charges were attracting each other. Do you understand? Sometimes when you are sleeping in blankets and you rub your skin against the blanket real hard, you can see sparks in the dark room. And many of you might have done that. Why? Is because, again, because of your rubbing, one of the surfaces gets a negative charge, the other surface gets a positive charge, and the opposite charges attract each other. Okay, and because they don't have a circuit, they cannot flow. So they stay there and they attract each other, and when they attract each other, this electrical energy is converted into light energy, because of which you see that those sparks, okay, momentarily, and the energy is very small. Also, or also appreciate the fact that this attraction is really weak. Okay, so if for example I use a big paper, and I use the same phenomenon, my comb will not be able to pick up that big paper. Why? Because the big paper is too heavy. The weight is greater than these weak forces of attraction. Okay, so therefore you should use only small pieces of paper which are very light, so the weak force of attraction can easily pick them up. Do you understand that? Okay, so this was this. And so how do we get positive and negative charges? So yes, Zainab, you were correct that when I rubbed, some electrons got lost by the atoms, and so they acquired what charge?
Positive.
Right. So the atoms that lose the electron will acquire positive charge, and the atoms that are acquiring the electrons will get a negative charge. So I don't know here if comb was the electron donor or the paper was the electron donor. I don't know. But whatever, one of them gained and one of them lost. And therefore, the one that lost was positively charged and the one that gained was negatively charged. Okay, I hope that is clear. Okay, now another thing, when I used a damp comb, it was not able to attract. Why? Though it's made up of plastic, same material. You know why? Because water is a conductor. Pure distilled water is an insulator, but I'm talking about normal water, which usually have minerals, okay, mineral ions. Because of those mineral ions, this, simple tap water or even drinking water, until and unless it is 100% distilled, it is a conductor. Okay, so because it was damp and because it had water, water is a conductor. Therefore, it conducted the charge away. The charge could not stay in one place. See, for you to see this phenomenon, the charges have to stay. That's why static electricity. Because you see, if they flow away, they are no longer there to attract the pieces of paper. Do you understand me? Also appreciate this spoon couldn't attract it, though I rubbed it so much. It also acquired charge when I rubbed it. It acquired charge. But you know what happened? Because I am holding it. See, my hand is in contact with the spoon, and my hand is also a conductor. My body, a human body, is a conductor. So the charge, whatever charge it gained, it flowed to the ground through my body. It flowed to the ground through my body. Do you understand? Therefore, the charges were not here to attract the pieces of paper. Did you understand me? So, therefore, if I rub any conductor, metal conductor, it will not be able to attract the pieces of paper, okay, no matter what you do. And
Miss,
in case of damp comb as well, because water was a conductor, it couldn't. Yes?
what if you use gloves, like cotton gloves, like the yarn ones?
Okay. Yeah. I don't think this metal conductor will be able to do that. Well, we have gloves, right? Okay. Sidra, can you get me gloves? Sidra? Okay.
It won't be able to still.
You know what? Yeah, gloves. You know, for gloves, okay. Now, even if I do use a glove, I think, I haven't tried it, but I think this metal conductor will still not be able to pick up these pieces of paper. You know why? Because it's still a conductor, and this spoon is really big compared to the pieces of paper, and the charges will distribute themselves throughout the spoon because it's a conductor, remember. So whatever charge is, for you to see this phenomenon, the charge has to stay exactly at the place near the pieces of paper, because remember, this attraction is very weak. Let me try. I have these gloves. I'm wearing these gloves. Okay, now I have gloves on. Please show my gloves. Okay. So again, now let me hold this. This is a spoon. Okay. I'm again rubbing it. Show this way. No. See? It's not picking it up as I expected, because charge is getting distributed throughout this spoon and it's not enough to pick up these pieces of paper. So, therefore, you will see this static electricity usually in insulators. Now, if you want to see in conductors, you have to insulate the conductor so that the charge is not allowed to move anywhere. Then you can see in a conductor. Yeah. Okay. Okay. So now let's talk about. Okay, let's explain this insulator conductor phenomenon. I have made a few diagrams here. Me here. Okay, this is upright करो ना इसको upright करो. Yes. Yes. See, this is a neutral object. Whether it is a conductor or an insulator, in both situations, whether it is a conductor or an insulator, in both situations, every object normally is neutral. What do I mean by neutral? Meaning that positive charges are cancelled by negative charges. The amount of positive and negative charges are equal, and therefore they cancel out each other. And so overall, you don't have any charge on the whole object. Okay, if for example there are 1 2 3 4 5, 1 2 3 5, 3 is 15. So I have 15 positive charges, I have 15 negative charges. So plus 15 minus 15 cancel out each other. And so I have a neutral object, no charge. Okay, whether conductor or insulator. Now, charging comes in when you have more positive than negative. Now, can you see you have more negative as compared to positive? So overall, this object is negatively charged because it has more negative compared to positive. And similarly, an object will be positively charged if you have more positive than negative. So overall, this object will be positively charged. Okay. Now, this is a charged insulator. Now, an insulator, what is an insulator, by the way? Can anybody recap real quick? What's an insulator?
Which does not conduct electricity or heat.
Right. It does not allow the charge to move from one part to the other. I mean, they may be able to vibrate around their fixed position, but they don't move from one end to the other, right? So if I, for example, when I rub the comb, for example, this is my comb. For example, this is a diagram of a comb. When I rubbed it, the part that I rubbed gained more negative charges. Can you see there are more negative charges than positive charges? This end has more negative charges. This end is neutral, all positive. Can you zoom into my diagram so that they can appreciate? Okay, so this end has more negative charges as compared to positive charge. So this is a negative end. I can say this is the negative end of the object and this is the neutral end. So relatively it is positive. It is more compared, when you compare to the negative end, this is positive. But because this is an insulator, this negative charge is not able to move. Okay, so this end will stay negative. It won't distribute itself. This negative charge is not able, these electrons are not able to move this way. By the way, we don't have mobile electrons in insulator. Do you remember from chemistry the structure of insulators? What are insulators? Can you give me examples of insulators? Like, metals are conductors, right? Metals are conductors. So what are insulators? Are they metals? Are they?
Glass,
Non-metals.
Glass.
Yes, they are non-metals. And do we have any other examples? Hydrocarbon.
wood, glass,
Very good.
Polymers.
Right.
rubber,
Yes, and then we have these plastic. What is plastic? Plastic is a polymer. It's plastic. It's a polymer. It's a hydrocarbon. Okay, this is also an insulator. Then fur. This is also, what is it? This is also an example of polymer. It is fabric. Okay, again, so this is also hydrocarbon. Okay, yeah, nylon, silk, cotton, paper, wood. All these are examples of insulators. In insulators, we have molecules. They are tightly bonded to each other. We don't have mobile electrons. Mobile electrons are only found in metals that can move. Okay, but this is only for your explanation purpose. I will show you another diagram in which I have shown molecules. So molecules align themselves in such a way that you have one end negative compared to the positive. Now, if this was a conductor, then again I have a negative end. Now here, but because it's a conductor, this negative charge can move. Now, no need to zoom in. Okay, this negative charge can move, and so it will distribute itself, so you cannot see negative end and positive end. The whole thing will get negative. You won't have like, this is called separation of charges. Here you got poles. This was more negative. We can call this the negative pole of the object. We can call this the positive pole of the object. Here we cannot do that because this will distribute itself. So this will be just as negative as this one. So the whole thing will be negative. Okay, understand this difference between insulator and conductor. So negative charge will distribute itself due to repulsion and conduction. Also appreciate the fact that like charges repel. They will not stay together. They will try their best to distribute themselves. They will try their best to move away as far from each other as is possible because they repel. Here they are forced to be crammed up in this end because they are not allowed because of the insulator nature of the object. Okay. Now, what was the other thing? Now, this is called induction, but I will come to induction later. First, let me explain you. Okay, another thing is that never ever will positive charges move. Okay, remember this. Positive charges cannot move. You know what are positive charges? Positive charges are atoms that have lost electrons. And negative charges can be anions, negatively charged ions, or they can be mobile electrons. If you're dealing with metal, here, then you have mobile electrons. But if you're dealing with an insulator, then this can also get negative charge. But here in this case, they will be anions. Okay, temporary. This, by the way, this is static electricity or even this current electricity. These are all physical changes. This is temporary movement of electrons. There is no chemical change going on in here. So this is an example of physical change. Okay, because this is temporary jumping of electrons. They stabilize again, they come back to their neutral position. Okay. Okay, I will go on to induction later. Let's first, so here in your book they have talked about positive and negative charges. Okay, and they have used rubbed polythene strips. Okay, polythene again is an insulator. So whatever, by rubbing, whatever charge it will get, it will stay there. Okay, and okay, the force between electric charges decreases as the, okay, also try, also remember the fact that the force of attraction or repulsion will decrease as the distance between the charged objects increases. Okay, so the force of attraction or repulsion is inversely proportional to the distance. Okay, inversely proportional to the distance. Okay, now here in this, they are simply explaining you the structure of atom. I think you guys have already done that. I'm not going into that. This is a simple structure of atom. Okay. Um, and then they're asking this question: how does polythene become charged when rubbed? So the answer is the same. What is the answer? How does polythene become charged when rubbed?
The the
Electrons are lost or gained from
yeah,
the
and then
rubbed object.
Right, right. Okay, another thing, many students have been asking this: how do we know if a thing is positively charged or negatively charged? How do we know? Well, there is no hard and fast rule that comb or polythene or polyacetate, whatever that is, polythene strips, these will get positively charged or negatively charged. They can get any charge. That is not the point. They will not ask you that question. That's not the point. You have to understand all these phenomenon. How do the charges behave with each other? If they ever ask you what charge does a particular rod get at the end of the experiment, they will give you hints. They will give you hints. So you will have to use your understanding, and you will have to use the information given in the question to determine what charge will that rod get. Okay, you don't have to learn that polythene will get a positive charge, cellulose acetate will get a negative charge, fur will get a positive charge, and silk will get a negative charge. You don't have to learn all of that. Okay, the information will be given in the question, and as we proceed on, you will be able to figure out, uh, uh, you know, uh, given the information in the question, you can figure out what charge a rod is getting. Okay, now let's move on to the gold leaf electroscope. Sidra beta, can you please? Okay, gold leaf electroscope. Okay, what is an electroscope? Now, this is a device. It's really simple. Okay, and it has two purposes. The purpose is to detect a charge. In fact, it has three purposes. Okay, it detects a charge, and it also helps us find out if a material is an insulator or a conductor. In fact, it has only two functions. This is not a function. We have to charge it ourselves. And if we know what charge we have given to the electroscope, we can carry these two functions out. I mean, even if we don't know the charge, we can find this out if the material you have brought close to it is an insulator or a conductor. But this is not a function. We can charge it. And if we know what charge we have given to the electroscope, we can find out the charge of the other material. Now, how does it work? First of all, let's zoom in to the diagram. Let's discuss these parts one by one, and then we'll discuss their function. So it's nothing. It's just a leaf. Okay, you can see this leaf. This is a gold leaf and this is a metal plate. Well, you can have two leaves as well. There is no hard and fast diagram for this. This diagram can vary. You can even have two gold leaves. Okay. And but the important parts are that you should have a metal cap and a metal rod which is in connection with the metal cap at the top and the leaves at the bottom. And then of course you don't want the leaf to move due to any drought or wind breeze, because you want to uh, because the movement of this leaf will tell you if there is charge on this object or not. And therefore you want the leaf to move only due to repulsion or attraction. You don't want the leaf to move due to any wind. Okay, so therefore they have surrounded it with these glass panes so that no wind can disturb the movement of the leaf. Okay, and then you have this insulated base. Why? Because you don't want any charge to be conducted to the ground, or to conduct it to any nearby conductors that there might be. Okay, so these are the important things about this electroscope. Okay, now first of all, I will do this. I will first of all learn how to charge it. Now you can charge it two ways. You can charge it, there are two ways. One is induction, the other is by conduction. Okay, now what do I mean? By the way, we can charge any object by three ways. Let me write it down for you. We can charge any object three ways. Friction. Okay, you can charge by three ways. One is friction, the other is conduction, and the third is induction. But for electroscope, we will only, with friction, you have already seen. When I was rubbing the comb with my sweater, I was charging it by friction. That you already saw, right? We're not going to use friction for electroscope. For electroscope, we will carry out conduction and induction. Because you see, in friction, we don't know which object got which charge. Finding that out is difficult, so it's not going to help us with the electroscope, because we need to know what charge we are giving to the electroscope. Okay, so conduction and induction. Now I want to share my screen and show that website. So turn this off and then share the screen here. That website. Yeah, Google Chrome. This one. Yes. Yes. Can you see my screen? Okay. This is charging by conduction. Can you see my screen? Can you
Yes,
see?
miss.
Okay.
Yes.
Okay. Alhamdulillah. Okay. Charging by conduction. Now, we are using an a charged rod. Remember, the rod has to be an insulator which is charged. Okay, pay attention to my words. What did I just say? Rod should be an insulator but charged. Insulator meaning it can be polythene rod, it can be cellulose acetate rod, it can be, I don't know, और भी बहुत सारे होते हैं ना. Yeah, it can be, basically it has to be an insulator, but by rubbing or by other methods you have to charge it. Why? Because we don't want this charge to be conducted away. So you cannot hold this rod with your hand, because if you will ah if yeah, it's an insulator, so yeah, you can hold it with your hand. Yeah, okay, sorry about that. So it's an insulator, it won't charge, the charge won't flow away, so you can hold it. uh, but it has to be an insulator, and it has to be charged. Okay, and you should know the charge on the rod. Okay, now when, for example, this particular picture that I am using for explanation has positively charged rod. Now electroscope is initially uncharged, we are trying to charge it by conduction. Okay, now the a rod is positively charged, the electroscope is uncharged. Okay, now because there is positive charge on the rod, it will attract electrons. Now of course this electroscope is whole metal, all the way from the cap, rod, and leaves. The whole thing is a metal. So, of course, it has mobile electrons. Now, these mobile electrons will be attracted towards the top knob due to attraction between opposite charges because the rod is positively charged. So, electrons are being attracted towards the top, leaving the positively charged cations behind at the bottom on the leaves. So you have separation of charges here going on, right? The negative charge has separated to the top, leaving the positive charge at the bottom, right? Now, when the rod is touched with the cap, when the rod is touched with the cap, remember this is charging by conduction. For conduction, we need contact, we need physical contact between the knob and the rod. So when the cap touches the rod, there is physical contact, because of which what happens when there is when there is physical contact between the rod and the cap? Who will tell me? Amna?
Electrons will flow.
Yes, please raise your hand and then I will let you. Amna, can you tell me?
Yes, miss. Miss, can you repeat, please?
Okay, Zainab.
Electrons will flow from the electroscope. It will be
Yes, very good. Yes,
charged.
electrons from the cap will flow to the rod. Can you see now the signs of positive charges are less in number? Can you see the signs of positive charge are now less in number as compared to the positive charges? Can you clearly see that? Right. Why? Because many of the positive charges have been neutralized by the electrons, where they've been neutralized. Okay. Now, if we remove the rod, what happens? The positive charge, because like charges repel, so they want to move away from each other as much as possible, so they will distribute themselves throughout this metallic structure in such a way that they are farther away from each other as much as is possible, and in the process they will distribute themselves uniformly. So now we have a positively charged electroscope. Did you understand? Now I
Yes, miss.
that okay, ये किसने बोला yes miss?
I miss.
Okay,
Zainab.
Zainab. Okay, Zainab, can you please explain us how can we induce the electroscope negatively? If we wanted a negative charge on the electroscope, what changes will you bring?
We'll charge the rod negatively.
Very good.
Like we'll,
Yes. Yes, we will use a negatively charged rod. And so what will happen if we use a
so
negatively charged?
now the electrons from the rod will go into the metal cap. They'll flow from there.
Yeah, so use these steps. Okay, use this step, these steps. So you will bring the negatively charged rod close to the metal cap. The electrons will be repelled away to the bottom, the leaves. Okay, at the bottom we have the leaves, so the electrons will be repelled towards the leaves, and the positive charges will be attracted towards the cap, right? And then when there is physical contact between the rod and the cap, what will happen? The electrons will flow from the rod. Do you get it?
To the
From
cap.
from the rod to the cap, neutralizing the positive charge. And so you will have only negative charge left behind, which will distribute itself. So you will have a negatively charged electroscope. Can you explain this whole process in your own words with these steps, with diagram? Can you do that? Can you guys do that? Or you want me to do it for you? Because this question might be asked. That's why I'm asking. Okay. Are we clear on this? Should I move on?
Yes.
Okay. Now,
Yes.
okay. Then charging by induction. Now, for this, you have to understand what induction is. Does anybody know what induction is? Come on, guys. I know it's late night. Are you sleepy?
No.
People in Riyadh don't sleep this early, do they?
They don't.
Yeah, I know that. Okay. Okay, so what do you know by induction? Okay, can you turn the camera on? Come on, Hafsa, Hala, Amna, come on.
Miss, I think induction is when we attach one object to the circuit and
Attach?
the other one
Did you say attach?
when we.
Yeah. It's okay. It's okay. I am asking you because I want to know if you use the word attach.
When we
Yes.
when the charges flow through one object, like when we contact it to the circuit, and for the other object it is already charged and it should be an insulator.
Yeah. Okay. So
Is it
yes. Yes. Who was that? Does anybody else want to add? Yes.
is it that when a charged object is brought near an
Very
uncharged
good.
object?
Yes. Thank you. Yes, Amna. Please correct this mistake. That in induction there should not be any contact. Only in conduction and friction. Remember, there are three ways of charging: friction, conduction, induction. In friction and conduction, you have physical contact, you have touching going on between the two objects. But in induction, remember this, and I'm repeating, in induction, there is no physical contact between the two objects. If you write the word attach, your answer will be wrong no matter what you have written. You will not be credited for it. You know why? Because if you write the word attach, then you are explaining conduction, not induction. Do you get me? So that's why I stopped you when you use the word attached. When the charged object is brought close, can you see my camera? Can you see my camera?
Yes, miss.
Yes.
And should I stop sharing or is it okay? Because
It's okay.
It's okay.
okay, yeah, okay. So when the charged object is brought close to the neutral object, then whatever the charge is on the charged object, it will repel. Like it will repel the negative charges and, of course, will attract the positive charges. Now, this, of course, uh, positive charges don't move. Okay, remember that. So they will stay where they are, they won't move. Okay, but because all these, it will be like this. So this diagram is a little wrong. I mean, they will not move. Okay, but you get the point that this end of the object is negatively charged, and this end of the object is positively charged. Okay, so because why is this? So this is called polarization, or this is called separation of charges. Because of the repulsion by the negative charges got repelled to the opposite end, leaving the end which was close to the charged object positive. So the end which is close to the charged object will get the opposite charge, and the other opposite end will get the same charge as the charged object. This is called induction. This is called induction. Okay, if there is contact between the objects, the charges will flow from the charged object to the neutral object. So then, if you make a physical contact, what will happen? The electrons will travel here and will neutralize these positive charges. So you won't have separation of charges anymore. Okay. So now, okay, stop the camera. I want to get back to this sharing screen. Now get back to my sharing, the website that I'm sharing with you. Now this other picture is showing how we can charge the electroscope by induction, and also note down that the rod is not touching the electroscope. It is not touching the electroscope. So here we have a positively charged rod, again an insulator, and when it is brought close to the cap, it is attracting electrons towards the knob and leaving behind the positive charges on the leaves. Okay, make a note that the rod is still not touching the cap, but the cap is grounded or earthed. What does that mean? What is earthing?
Means
Connected to
with
the
the
wire.
earth.
Yes, connected to the earth. And what does that do?
That will
It
charge
moves
it.
the electrons into the earth
Okay,
to
okay. You
prevent the
guys
charge
can, you
building in
can
the
raise your
objects
hand.
around
You
it
guys can
or
raise your
not.
hand. Okay, yes, Amna?
Yes, earthing is when we have to prevent a charge building in an object, so we earth it by connecting it with a wire to the ground,
Yes,
so that
yes.
the charge flows away by the conducting materials.
Yes. Okay, very good. Yes, that's what earthing means when we connect a charged object to the ground, because ground is again a conductor. It conducts the excess of charge away. Now, remember, it's always the electrons which are moving. So if you are connecting a positive charge to the ground, the electrons will flow from the ground to the positive charge, neutralizing it away. And if you are connecting a negative object with the ground, then the electrons will flow from the negative object to the ground. So, whatever the situation might be. Now, in this case, the cap is negatively charged. It has excess of electrons. Now it is grounded. But also remember that these electrons are held together by this positive rod. The positive rod. So the attraction towards this positive rod is not allowing the electrons to go to the ground. The positive rod is more positive than the ground. So it is not allowing the electrons to move towards the ground. So eventually, what happens is that this positive rod has so much attraction that it attracts the electrons from the ground itself. Okay. And so now you have excess of electrons. Okay. And when you remove the rod, these electrons will distribute themselves because they repel each other, they distribute themselves. And so the whole electroscope is now, so you have more negative than positive. The positive didn't go anywhere, they're there. But because there are more negative than positive, overall, the whole electroscope is negatively charged. Okay, so this is how we induce an electroscope negatively. Okay, this is by induction. Now, how can we induce an electroscope positively? What will be the difference? How can we induce the electroscope positively? Yes, Ajwa, raise your hand. Yes, Amna, I can see your hand raised.
Yes, miss, by bringing a negatively charged rod near it.
Yes, by using a negative charge. Okay, so you understood how to induce an electroscope positively or negatively, both by conduction and induction. Okay, now this is a good diagram. Now, this is how the insulators are. Remember, in insulators, you don't have mobile electrons. So let me. So can you see these small yellow circles they have made? I don't know how to zoom in. How do you zoom in? This is how you zoom in, right? Yeah. Okay, more. Yes. Okay. Yeah. Now look at these yellow circles in the diagram. Now these are, for example, suppose these circles are the molecules of insulators. Now insulators don't have mobile electrons, then how do they get polarized? Polarized, what does the word polarized mean? Separation of charges. Okay, both the charges are all the time available in all the objects. It is their separation which makes them charged. Okay, remember this. No charge is created or destroyed. It is only their separation. Okay, so in insulators, because there are no mobile electrons, the molecules have electrons and protons. Remember, I mean, the atoms have electrons and protons, and atoms together make molecules. So molecules also have electrons and protons. And so because of these charges, because of the polarized, here you can see the positively charged rod at the top, which is brought close to the insulator. Now this insulator can be a piece of paper. Okay, And now you can see that the negative parts of the molecules are all facing upwards. Why? Because they are attracted towards this positively charged rod at the top. So they have all aligned themselves or arranged themselves in such a way that their negative parts are facing up. And the positive poles or the positive ends of the molecules are facing down or facing the bottom. And this separation of charge is what enables the paper pieces to be lifted and be attracted towards the charged object, which is at the top. Do you get me? So, this is a good diagram indicating the attraction of uncharged objects after rubbing. Okay, this diagram will be, how will this diagram change if I am showing a conductor? How will this diagram change if I'm showing a conductor instead of an insulator?
All the electrons will be at the
Yes, all the electrons. I will show the electrons moving towards the top. And I have made a diagram here. Let me see if I can. Here, can you please show them this? Yeah, this is how a conductor will look like. This is how a conductor will look like. So you had cations embedded in a mobile sea of electrons, and if there is negative charge, if I have brought a negatively charged rod at the top, the negative charges will repel. And can you see now the electrons have repelled to the bottom of the aluminum foil? For example, aluminum foil is a good example of a conductor. Okay, leaving this upper part to be positive, upper part is positive and the bottom part is negative. And so the aluminum foil will also get attracted if it is not allowed, if the charges are not allowed to flow, and if it is of the same size almost as the rod. Okay. Okay, so we have done the charging of electroscope. We have, okay, we can also use this electroscope to find out if something is, or in order to find out the charge on the rod. If, for example, we don't know the charge of a rod and we have a charged electroscope and we know the charge on the electroscope, how can we detect the charge on the rod? Let's see. Yeah, yeah, stop sharing. I'm stop here. Okay, here. Let me use this. Okay, if this is an electroscope and I have induced it, or let's say I have charged it negatively. Okay, this is negative. Okay, now I have a rod here. I don't know what charge is on it. Okay, now when I bring it close, sorry, this diagram got wrong. Oh, sorry. The metal case should be here, like this. If this is negatively charged and this is the rod, and I don't know the charge on the rod, but when I bring it close, the leaf rises even more. What is the charge? The leaf
It's
rises
positive
positive? Explain.
because unlike charge attracts.
Unlike attract, okay, so the leaf has diverged more.
Can I miss?
Yes, Zainab?
The rod is charged negatively.
Okay,
Because of the repulsion force, the electrons in the electroscope moves downward, and the positive charges stay where they were, so it attracts.
yes. See, if this is negatively charged, let's suppose if it is negatively charged, when I bring it close, uh, I'm getting confused. ये किस तरह से था? Towards the leaf rises away from the plate. Okay, Sundas will explain. Okay, yes, Sundas.
So when you like bring the negatively charged rod next to the that plate, the negative charges repel. So it's
No, no,
gonna.
no. When the negative charge rod is brought close, see again there will be separation of charges. You will have positive attracted towards the top, and you will have repulsion of electrons as far away
Yeah.
towards the bottom as is possible. So there is more accumulation of electrons, and negative charge will accumulate, and there will be more repulsion. There will be more repulsion between the leaves. And so, whenever there is more divergence, whenever the leaf gets elevated more, you understand that the charge on the object is the same as the electroscope. Remember this. I am repeating. I'm repeating myself. Whenever a rod is brought close and you see that the leaf has risen even more, that means the charge is the same on the rod and the leaves. Same charge. Do you understand? Now I yes.
Yes, miss.
So when the charge is same, how is it attracting?
Sorry. Can you repeat your question?
When the charge is same, how is it attracting towards the rod?
No, the rod is negatively charged, so the negative charges are gonna repel, and so they're gonna accumulate on
See,
this side, and this side is gonna get positive.
okay. See, I told you that the charges are neither created or nor destroyed. Okay? Please listen to this carefully. Now, this whole metallic structure from the cap till the leaves, this is whole metallic. Okay? This has both positive and negative charges normally. Please mute yourself, Shami. Now, when you are bringing a positive rod near the cap, remember you are bringing the rod near the cap, not this whole thing. This is insulated. This is an insulated box. Okay, don't confuse. I'm not bringing the rod close to the leaves. I am bringing the rod close to the cap. Okay, when I bring the rod close to the cap, because there is negative charge on the rod, the positive, whatever positive charges there are, they are getting attracted towards the metal cap, leaving more negative charges towards the bottom. So you have more negativity accumulated in the leaves, and similar charges repel. So they move apart or away from each other. So you will see that the leaf will rise even more. Do you understand? Did you understand me?
Yes, miss.
Is there any confusion?
Miss, but in the case of induction, we earth the we earth the leaves. So in that case, the cap as well as the leaves, they all will be of the same charge, right?
Yes, but yes, there are still some positive charges left. Yes, but they are overall more negative than positive. But when you will bring this, you are further accentuating, you're further separating whatever charges there were left. Did I answer your question, or do you still have that question? If you have, then please repeat your question.
Miss, can you share your screen? I wanted to ask from there.
Okay. uh okay, share screen करना जरा. Yes. Yeah, scroll up. Okay, now hold this.
Yeah,
Yes.
miss, over here, look in the induction part.
Yes.
After we bring the charged rod near,
Yes.
so the whole shouldn't at the end the whole of the
Yes,
elec
electroscope is negative. Yes.
electroscope gains the same charge, right?
Yes. 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 And so that is that confusing you? I mean, now you're saying how did we get the positive cap? Is that the question?
Yes.
Yeah, so yeah, I answered that question that yes, here overall you have more negative than positive. Remember, even if they are showing you negative doesn't mean that like there's no positive at all. Okay? It just means that there is more negative than positive. There are few positive there. Do you understand me? So when you will bring a negatively charged rod, those few positive will again accumulate towards the top. Do you get me? Don't get confused.
Yes, miss, I got it.
Okay. Now let's okay, I think we are running out of time, but let me just finish this electroscope thing at least, and then okay, where were we? Stop the video. And then where was I get confused with the flow of my lecture. What was I what was I teaching? I forgot. Can anybody remind me? So yeah, we charged. Oh yeah, okay. So how can we use the electroscope and detect the charge on the rod? Okay, stop sharing. Stop sharing. Okay. Okay. Now, if for example, now you can, play with this, and you can, make your own questions. Like, for example, if this is negative charge, if this electroscope is negatively charged, and I bring a positively charged rod, what will happen?
The leaf will fall down.
Sorry, who was that? Can you turn the fireplace off?
Hala.
Yes, okay, Hala. What will you see? What did you say?
The leaf will lower itself.
Yes, the leaf will collapse, yeah, or the leaf will fall down. Why? Can you explain? Okay, Zainab, can you explain? Yes, Hala, okay.
Because the negative electrons will be attracted towards the plate.
Very good.
And
Yes. So when we will bring the positively charged rod near the cap, it will attract the negatively charged electrons up. Okay, and so you will have less negativity here. Okay, and so the leaf will collapse. Okay. Okay, so this is how we can use this electroscope to detect the charge on the rod, provided we know the charge on the electroscope. Okay, for that it is important. Okay, if you don't know the charge on the electroscope, then what can you find out about the charge on the rod? What can you find out about the charge on the rod? Yes, Zainab?
If we don't know the charge of
I
the
cannot hear you. Can you higher your volume? Can you turn on the volume?
if we don't know the charge of the electroscope and we bring a rod near it, if it attracts, this means the charge of the electroscope, the plate is negative or positive. If it attracts, the if the rod is positive, then the plate it's negative
Okay,
and the
let me give
lower
you.
part is positive.
Okay, so whenever the leaf rises, same charge on both. Same charge on electroscope and rod. Okay, if the leaf collapses, then opposite charges on the electroscope and the rod. Okay, remember this. At least you can deduce this much. I mean, you can find this much out even if you don't know the charges on the electroscope or the rod. You know this much. If the leaf is rising, both of them are having the same charge. If the leaf is collapsing, both of them are having opposite charges. Now, it depends on the question what they're asking. Are they asking the charges? But they will give you some information to find out what charge is on what. They will either give you the charge on the electroscope, or they will give you the charge on the rod and find the other one. Okay, and ask the other one. So you will know. So if you know this rule, it will help you. Leaf rises, same charge on the electroscope and rod. Leaf collapses. And remember, this is only for induction. This is for induction. Okay, meaning no touching. No touching between the cap and the rod. No touching. This is for induction. Okay. Another thing, if we conduct, if we charge this electroscope by conduction, okay, I remember again, I'm sharing my screen. I told you the electroscope can be induced by two ways: conduction. यार ये किस तरह से है यार? Just press this. ये. Oh, okay, okay. This. Uh, we discussed that the electroscope can be induced two ways: by conduction and by induction. By conduction, remember, I forgot to tell one thing. By conduction, look at this. By conduction, the electroscope will get the same charge as that of the rod. This is induction. This is conduction. Okay, conduction. The electroscope will get the same charge as the rod. And by induction, the electroscope will get the charge opposite to that of the charging rod. Okay, opposite to that of the charging rod. I mean, when you are charging the electroscope. But when you are trying to find out what the charge is on the electroscope, I mean, you are not charging it, but you're trying to find out what charge there is. Then you use this rule that I told you, that if the leaf rises, same charge on the electroscope and the rod, and if the leaf collapses, then opposite charges. Okay, with practice uh, you will make out what I'm saying. Okay, another thing, the speed of the falling and rising of the leaf will indicate if the rod is a good conductor or not. Okay, the speed at which the leaf falls, if the leaf falls or rises very quickly, that means that the rod was a good conductor. And if the leaf falls slowly, then the material is a poor conductor. Or if the leaf does not alter, then the material is a good insulator. Okay, but for this, you'll have to touch. I mean, this is only good, this conclusion is only good if you are touching the rod with the cap. Okay, touch the cap of the charged electroscope with different things, such as a piece of paper, a wire, your finger, a comb, a cotton, blah, 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 all of this. When the leaf falls, why does the leaf fall? Because whatever the charge is on the electroscope, it will try to balance out. If, for example, you have touched it with a conductor, and if your electroscope is negatively charged, the charge will flow into your conductor, in the conductor that you just touched. And vice versa, even if it is positive, the electrons will flow into it, and so on and so forth. So when the leaf falls, you have to see if the leaf is falling rapidly or slowly. If the charge if the leaf is falling rapidly, that means the object is a good conductor, and if the leaf falls slowly, then that means the material is a poor conductor. Okay. Okay, when the leaf falls, charge is passing to or from the ground through you and the material touching the cap. Okay, so this is done. Okay, now let's discuss this diagram real quick, and then we'll do the end of chapter questions. Okay, and this I think I have already discussed. Electrostatic induction. Again, this is induction, meaning the rod is not allowed to touch these spheres. We have two metallic spheres labeled X and Y, and they are standing on an insulated base. Okay, this rod is negatively charged, and so this negative charge is repelling the. Now these are metals, so we have a sea of mobile electrons, right? So these electrons will be repelled away from the negatively charged rod to the opposite side. So you have this end all negatively charged, leaving the positive charge near the negatively charged rod. Right now, after what has happened here, this is called, what is this called, Sundus? Yes, this is called induction. Also separation of charges, you can call it polarization. Now we have two opposite poles, negative pole and positive pole. So this is called polarization or separation of charges. Now, when we separate the two spheres, they are no more in physical contact with each other. So no flow and nothing. So you can see that there is still this negative pole, and this X has positive Why? Because these positive charges are not allowed to move, and positive charges don't move in any way, but this is only diagrammatic representation. Okay, this is only diagrammatic, just to say that this is relatively positive to negative. Okay, and then when we remove the rod here, they, because the like charges repel, they have distributed themselves. They have distributed themselves as far away as is possible, right? Now you will say, how did the positive charge distribute itself? Well, you said positive charges don't move. No.
Yes,
Yes. Is that the question, Zainab?
yes, like how it they distributed themselves.
Yeah, okay. Yeah, okay. Sundus is trying to answer. Yes?
Maybe the atoms on the other side of the sphere exchanged electrons or something.
Yes. See, I told you, it doesn't mean that now this positive has no electrons at all. It doesn't mean that it has zero electrons. No, it does have a few electrons, but yes, positive is more than negative. So it is the those few electrons will rearrange themselves in such a way that these positive charges will distribute themselves, will get distributed this way. Do you understand me? Did you understand, Zainab?
Yes, miss.
Yes. Remember, see, what is darkness? It is the absence of light, isn't it? So if I say that darkness is now uniformly distributed, what does it mean? That light, whatever light there was, that got distributed. Did you understand? So positive charge is the absence of electrons. Positive charge is actually the absence of negative charge. Do you understand? Okay. I hope you did. So I have covered most of the concepts here. Okay, let's real quick discuss these questions. There are only three questions and they're real easy. And then I want to discuss a few questions of my own with you. So question number one. Please, beta, straight pukro. Okay, two identical conducting balls suspended on nylon threads come to rest with the threads making equal angles with the vertical, as shown in figure 35.12. Which of these statements is true? This shows that A, the balls are equally and oppositely charged. Now let's discuss each and every option one by one. Let's see if they are correct. The balls are equally and oppositely charged. Huh? Do you think this is true? Why?
No,
Why?
if they would be opposite, they would attract.
Right. Very good, Maruj. So A is wrong. If they were oppositely charged, they should have attracted each other. But you can see that they are repelling, and also they are repelling to the same extent because they are making equal angle from the vertical. Vertical is perpendicular to the horizontal. Okay. The balls are oppositely charged. No. So this is, I mean, here you know that this option is wrong. But anyway, let's read the whole thing. The balls are oppositely charged, but not necessarily equally charged. No, this is wrong. It is again wrong because it says that they are oppositely charged. C, one ball is charged and the other is uncharged.
This is also
It's
wrong.
wrong.
No, both are charged.
Yeah, and try not to look at the back because let yourself think. Okay, let yourself think. I mean, you're not going to be marked on this or anything, but just think. So, okay, so who wants to discuss this option C? Yeah, Sundus, you want to discuss? Yes, uncharged means neutral. Yes, that's right.
Yeah, so if one ball is charged and the other ball is uncharged, they're not gonna affect each other because one doesn't have a charge.
But remember, when one object is charged and the other is uncharged and they are conductors, won't they induce? So, if for example,
Yeah, so even if they induce, they're gonna attract.
yes, so they will induce in such a way that they should. So, if one is charged, for example, if this is charged, if for example, this is positive, for example, so the other, so it will induce it this way, right?
Yeah, so that's what they're gonna attract.
Yeah. Okay. So, okay, let's leave it here. D. The balls both carry the same type of charge.
It's
Yeah.
correct.
Yes.
Yeah.
Correct.
Yes, this is what we can for sure say that yes, this is correct. Okay. If the other is uncharged, it will induce. It will induce, and it will induce in such a way that they tend to attract. Okay. So E, one is charged and the other may or may not be charged. See, if may not be charged, then this is the story. Then this is what's going to happen. If this is uncharged, it will get induced by the charged ball, and induction will mean attraction. So may not,
No, so D is the right
so
option.
that means E is also wrong. So it is D, which is correct. Okay? Is there any confusion? Anybody has question regarding this question?
No, miss.
Okay, question number 2. Explain in terms of electron movement what happens when a polythene rod becomes charged negatively by being rubbed with a cloth. Easy peasy. Zainab is the only one participating. Yes, Hala?
The loosely bonded electrons on the cloth are removed when the rod is rubbed, and that is why the polythene rod becomes negative
Okay, so electrons jump from which material to which material?
from the cotton to the rod.
From the cloth to the polythene rod. Okay, use the words used in the question. Yes, your answer is correct. Good job. So, yes, the outermost loosely held electrons will jump from the atoms of the cloth to the atoms of the polythene rod. Okay, question number 3. Which of the statements A to E is true? In the process of electrostatic induction, a conductor is rubbed with an insulator. A conductor is rubbed with an insulator. See, I just told you, if a conductor is rubbed, the charge will distribute itself.
Like the experiment we did with the spoon and the sweater.
Yes, when I rub the spoon with my sweater, did you see? We don't do that. Conductor, the charge distributes itself. Number B, a charge is produced by friction.
Most of the time, but not always.
Yes, Hamza, Huzaifa, Laiba, Shamim, Javeria. Do you think option B is correct? A charge is produced by friction?
No.
Anybody else? Do you think option B is correct? A charge is produced by friction?
No,
Because if it would be frictionized, so won't be the electrons would be distributed.
Yeah, but they did not mention if the object is a conductor or an insulator. They are just asking. Here they mention in option A they mentioned conductor, but in option B they did not mention conductor. So in the process of electrostatic induction, a charge is produced by friction. Remember, there are 3 ways of charging. I told you: friction, conduction, and induction. But in friction, we don't know which one is getting positive, which one is getting negative. But it does. Okay, Amna?
Yes, B is correct.
Yes, I think B is correct too. Okay, but let's go through all the options. See, negative and positive charges are separated in
Right, miss.
in the process of electrostatic induction.
Yeah.
Yes, they are.
Yes, they are.
No.
Yeah, induction, yes. Oh, yes, they are talking about induction. So friction cannot be, because remember, in induction there should be no touching, no physical contact. Remember, friction has physical contact.
Mm.
So this B cannot be correct. But yes, charge is produced by friction. That itself, this statement itself is correct, but in this question it is not correct. It is not satisfying the question that they are in that's not what happens in electrostatic induction. In electrostatic induction, there is separation of negative and positive charges. That is correct. D. A positive charge induces a positive charge. Is that correct?
No.
No, miss.
No. Positive charge will attract negative charge,
Yeah.
will induce a negative charge.
Yeah.
Electrons are sprayed onto an object. That
No.
is absolutely wrong. Okay. So, did you see that on one go I felt that B is correct? But when I nevertheless I did check the rest of the options, and then I saved myself from choosing B incorrectly. Okay, so even if you think you know the correct answer, please go through all the options. Even if you think they are wrong, go through all the options. Be 100% sure that your correct option is the correct option. Do you understand? Because this happens. You know, when you are short of time, you see one option, oh, this sounds correct, and you immediately mark it off when you have a better option left behind. Okay. Okay, so we are done with this. How much time is left? Okay, let me take 10 more minutes, and I want to ask you a few questions. Okay, insulated box. Yeah, either. Okay. Okay. This is a question. Okay. This is a charged rod, and this is an uncharged electroscope. What do you think will be the effect on this electroscope of bringing this charged rod close to it before touching? Before touching. Yes, Amna, does your raise hand mean you want to answer? Yes? Okay, Zainab?
Miss, can you first like repeat the question?
Okay, this is an uncharged electroscope, and I am bringing a positively charged rod close to the cap. And remember, close to the cap, not to the other parts. So, what will be the effect on the electroscope? I mean, what will you see and why before the rod touches it? I mean, it hasn't touched.
The electrons would be distributed. The cap would have electrons, and the uh, leaf and the rod will have positive charge because of
Very good.
repulsion. So the leaf would rise.
Very good. Yes. Yes. So, yes, the negative charges will be attracted towards the cap, leaving behind positive charges. Can you see my charges? Sorry. So, you will see positive charges on this. And so, you will see that the leaf will rise, but it will have the same charge as the rod. Okay. Is there any effect on the leaf before the cap is touched? If so, explain why. Okay. Now, this another question. This is a negatively charged electroscope. I don't know the charge on this rod. I want to find out. I don't know. I am bringing it close to the cap, and I can see that the leaf is rising. What is the charge on the rod? Negative.
It's negative.
Okay, Amna, explain me. Okay, Shamim, explain me. Okay, Hala.
It's negative because the leaf rises, and you told us that when
Very good. Yes.
the
Okay. Yeah, but if the question asks you to explain, then what? How will you explain?
Miss, should I explain because I can't raise my hand?
because the positive.
Okay, let Hala explain because she.
Okay.
Yes, Hala, do you want to explain?
Yes, miss. The positive ones are attracted towards the plate, and
Right.
because of repulsion, uh, the leaf it
Right.
rises.
Right. Yes. So the electrons will be repelled towards the bottom, and so it will cause the leaf to be repelled more because there's more negativity accumulated. Yes. Okay. Let's move on to the next question. Okay, Maruj, you, if you want, you can answer this question. This is a metal can. Okay, and a charged rod has been brought close to this metal can. This metal can is uncharged. This metal can is uncharged, and we are bringing a positively charged rod close to it, what charges will be induced in the can, and how? What will be the arrangement of charges on this can? How will the charges be induced on this can?
The negatively charged will be near to the rod, and the positively will be opposite to it.
Right, right, right. It will be like this. So you will draw a diagram this way. I mean, if they give you a diagram this way, this is how you will make the charges on the diagram. Okay. What would you need to do in order to leave the can with a negative charge? If you want to induce this metal can with only negative charge, you don't want, I mean, you want an overall negative charge on this metal, what will you do?
Earth it.
Very
You would
good.
connect it to the earth
Very good. Very good. And so, how will you earth it?
by connecting a wire with the earth and the metal can.
Acha. Ek easy way of earthing. No need for a wire, anything. Just tap it with your finger. You are also earthing. When you are no, but this is static. This is static. You can tap it. This is safe. Yes, in current electricity, then don't use your body for earthing. Okay, but yes, for static, this is not dangerous. You can just tap it a little. When you will tap it a little, electrons from your body will move in, and remember to tap the positive side. Okay, what will if you tap, can these electrons move to the ground? Zor se bola. No.
No, miss.
Can anybody tell me, when I tap, can these electrons move to the ground?
Yes, if the rod is not over there, they can flow through the body to the ground.
Very good, Zainab. Very good. You said yes. No, they cannot, because the rod will not allow them. This rod is still holding on the force of attraction, remember? Yeah. So if you remove the rod and then tap, yeah, no. But if the rod is still there, the rod is holding on to these electrons. So the rod, when you tap, electrons will move from your body to neutralize this positive charge. And so you will have net negative charge on it. So you will not remove the rod. You will keep the rod here so that these electrons don't move. If you remove the rod, then of course these electrons will go to the ground.
Miss, I have a question.
Yes?
Miss, in the past paper, there was a question that a metal wire is attached to the can, and it was written state the order at which the rod and the wire should be removed.
Okay, you know what? In the next class, you bring the past paper questions that you want to ask. If it is simple, then you can ask me right now, but otherwise, I will have to see the whole thing. I will have to read the whole question and look at the diagram properly to be able to answer. Okay, so we
So
have
I'll bring
done,
it in the next.
sorry. Yeah, bring it, save it, and you can share the picture with me personally or in the group, and then we will discuss it, okay, in the next class. Okay, so let me just real quick be finished with this. Okay, what okay, so yeah, so we have done this, and so yeah. Okay, I have few more questions, but I think this is enough for today. It's already I think too late. Okay, so in the next class, I don't know. Okay, I have missed on electric field. I did not do electric field and electric charges. So inshallah, we will do that in the next class. I don't know if I can take a class tomorrow. Do you guys want a class tomorrow, or because then otherwise I will take your next class when I return to Riyadh. So if you guys want a class, and it will be 1 hour only because we have done most of the things, so we can discuss the questions, and we can do the electric field. It's not too much. It will be only 1 hour. What do you guys say?
Do it when you come back.
Okay, okay, fine. We'll do it when we come back. When I come back. Okay, then take care. Okay. Assalamu alaikum warahmatullahi wabarakatuh. Is there any question? I'm sorry, I forgot to ask. Okay. Okay. Assalamu alaikum.